Started with analysis of the column, that is determination of load carrying capacity of the column. The load carrying capacity of the short column and the long column are the different one. The long column can be easily buckles, hence its load carrying capacity will be the less as compared with the short column. Now first one we are going for the determination of load carrying capacity of the column. Load carrying capacity is nothing but the stress multiplied by the area. Then we are getting the load carried by the column. So load carrying capacity of the short column is given as load carrying capacity is equal to sigma cc multiplied by AC plus ASC into sigma SC. So this sigma cc is nothing but the permissible stress in concrete in direct compression. For sigma cc we have to refer IS 456 2000 page number 81. Table number 21 will be gives the value of the sigma cc. The value of the sigma cc will be directly depend upon the which grade of the concrete we are using. So the next one, AC is nothing but the net area of the concrete that we are providing. Then sigma SC is nothing but the permissible stress in steel, and this permissible stress in steel is also depend upon the which grade of the steel we are providing. Again, for the calculating of sigma SC, you have to refer IS 456 2000 page number 82, table number 22 will be gives the value of the sigma SC, and this sigma SC is nothing but the area of the steel we are providing in the column. So this is the formula that we are using for the determination of load carrying capacity of the short column. The next one we are going for the determination of load carrying capacity of the long column with the lateral ties are to be provided. Then load carrying capacity will be given as the load carrying capacity is equal to CR into sigma cc AC in plus ASC into sigma SC. So this factor is nothing but the load carrying capacity of the short column should be multiplied by the CR, and which is nothing but the reduction coefficient, and which is given as 1.25 into minus 1.25 minus L effective divided by 48 times B. This B is nothing but the least lateral dimension of the column. So load carrying capacity of the long column is CR times load carried by the short column. Then third one, if we are providing the spiral instead of providing the lateral ties, in that case load carrying capacity of the column will be increased by the 5%. In that case load carrying capacity will be given as load carrying capacity is equal to 1.05 into sigma SC into AC plus sigma SC into ASC. So this is the formula which is to be used for the determination of load carrying capacity of the column provided with the spiral or the helical reinforcement. Now we have directly started with the analysis of the column. So let us consider example. A short column of size 400 mm by 400 mm in section is reinforced with 8 bars of 20 mm diameter. Find the shape load carried by the column, and we have to use the working stress method, and the grade of material is M20 grade concrete is, and Fe415 steel is we have to use. Now first one we have to write down the given data. So width of the column is given 400 mm, depth of the column will be given 400 mm. Now here the column is reinforced with the 8 bars of 20 mm in size. So first we have to calculate the area of the steel reinforcement. So ASC will be the area of the steel reinforcement, which is equal to 8 times area of the 1 bar. It is nothing but the number of bars we are providing. So number of bars into area of the 1 bar. Area of the 1 bar is given as pi by 4 into diameter of steel bar. We are using the 20 mm. So 8 into pi by 4 into 20 square. So we are getting the area of the total steel provided in the column. Again the grade of the materials are given. M20 is given, grade of the concrete is given, and Fe415 steel is given. By referring IS 456 we are getting the value of the sigma cc, that is permissible stress in concrete direct compression, is 5 Newton per mm square, and this is the permissible stress in steel in direct compression is equal to 190 Newton per mm square. So once we are getting this design constant, then we are directly calculate the area of concrete given, because in case of the column along with the concrete we are providing the steel reinforced bar. So we have to calculate the net area of the concrete, that is AC is equal to gross area of the column minus area of the steel reinforcement. So gross area of the column is nothing but the size of the column, that is 400 mm multiplied by 400 mm minus area of the steel reinforced bar. So after simplifying this one, we are getting the net area of the concrete, which is equal to 157486.73 mm square. Then last step, we have to calculate the load carrying capacity of the column, which is equal to sigma cc multiplied by AC plus sigma SC multiplied by ASC. So this load carrying capacity is equal to 5 multiplied by AC value plus load in say 190 multiplied by 2513.27. After simplifying this one, we are getting the load carrying capacity is equal to 1264.95 kilonewton. So this is the SAP load carried by the given short column.